So the third of the homework questions. State two conditions under which a Poisson is suitable to use. Well, there are more than two conditions. They're only asking for two. Nick, can you give me any condition for a Poisson?
There's constant rate of random events.
Yep, they're constant rate, random events. Yep. Can anybody give me anything else?
Discrete.
Discrete. Anything else anybody can think of? Independent. Yeah, okay. So for part A, they've got events occur at a constant rate, randomly or independently. Okay, and singly there means they can only one can happen at a time. You can't actually get two happening at exactly the same time. You can get two in a time interval. But basically any two conditions got you those 2 marks for that first part of the question. Then we're given, in a 10-minute interval, we have a mean of 1. So I've written down over here, cars, it's 1 in a 10-minute interval. Part B, find the probability in a 60-minute interval. There will be exactly 3 cars. So what will our lambda be for our 60-minute interval? 60. Are we saying 60? 6, yeah. It's 1 in 10 minutes, so it's 6 in 60 minutes. So we've got a Poisson distribution with a mean of 6. That's in there. And we want the probability of exactly 3. That's how you do it from the tables. Exactly 3 is less than or equal to 3, take away less than or equal to 2. There's no need to use the tables. You could just have done it as a calculation using the formula. You could probably just typed it into your calculator and got the answer out if you've got a graphic calculator. But there's the answer over there, 0.0892, and that one is worth 2 marks. Part B, at least 5 cars. That's the probability x is greater than or equal to 5. Again, we don't usually like the greater than or equal to's. Nicole, what's that the same as if I want to write down a probability with a less than in it? Yeah, that's right, okay. 1 minus less than or equal to 4. So, there we go. They've turned it around over here. They've got that number from the tables, and they've done the taking away. There's an answer there, 0.7149, and that's again worth 2 marks. They're now telling us that other vehicles other than cars passing at a rate in 60 minutes. Let's read that full sentence, sorry. The number of other vehicles other than cars passing the observation point in a 60-minute interval is modeled by a Poisson with a mean of 6. Find the probability that exactly one vehicle of any type passes the observation point in a 10-minute period. We know cars is 1 in 10 minutes. How many other vehicles are we expecting in a 10-minute period? Sorry, someone said? 1, yeah. If it's 6 in 60 minutes, it's 1 in 10 minutes. So we're expecting 1 car in every 10 minutes, 1 car every 10 minutes, or 1 other vehicle in every 10 minutes. And we want exactly 1 vehicle of any type. How are we going to do that question?
Find the probability of 1 times the probability of anything other than 1.
I think you're going down the right track. It's not, you can't combine the two things. They're different things. They've said, look at the statement they've got here. You're interested in a car or no other vehicles. A car and no other vehicles, or no cars and 1 other vehicle. Okay, you can't lump the two things together. So we're going to work out different probabilities here. It's like a little tree diagram type thing, like really, in some ways. If we have a car and nothing else, that gives us what we want. Or if we have no cars but 1 other vehicle, that gives us what we want. They've got the probabilities down here of a car and no other vehicle, and they're timesing those together because they want them both happening. Or, which is add, no cars and 1 other vehicle, and they've given that to you there as a decimal. That part of the question there were 4 marks on, which brings it to 11 altogether. So there's 1 mark for coming up with that statement, 2 marks for the probabilities, and 1 for the final answer there.